Hunter. Thing up. Great. And can I just remind all the presentations that it's, presenters that it's 12 minutes with 3 minutes for questions. So I'll give you a 2 minute to go warning at 10 minutes gone. Thank you very much. Laura.
Hi, good morning. Oh, sorry, I've got my volume on here. There we go. Yeah, good morning. My name is Laura Hunter. I'm a scientist at the Animal Behavior and Welfare team at Ag Research in Hamilton, New Zealand. And today I'm going to be talking about a bit of a pilot study that we did on the development of acoustic sensors for detecting individual cow vocalizations. And just before I get started, I'd like to acknowledge my co-author, Paul Shorten. Out of the two of us, he's definitely the more computer sciencey person. So any questions regarding that, we'll have to go to him, and I'm definitely more the cow person. Yeah. So what is acoustic analysis? It's the process of capturing sound and using computer analysis to make noise, determine noises of interest, and use this to inform decision making. So acoustic analysis in a farm setting, I think there's a lot of different areas that it's useful for. I think one of the most interesting for me is this infographic on screen here of the pigs, where microphones are placed over top of the pens, and they're listening out for coughing. This is picked up, processed by the computer, and then sent to the farmer with detailed information about where that is happening. So the farmer can then make decisions about their management practices, which to prevent a disease outbreak and improve welfare. So I became interested in this acoustic analysis, really, and having discussions just out in the office with coworkers. My co-author, Paul, has been working with others in our organization using acoustic sensors to detect urination events from cows in an environmental science mindset, using this to assess how much urine is being deposited into pastures. So we started to think, what else could we use these sensors for? And of course, we're looking at cow vocalizations. So cattle and cow vocalizations isn't really a new thing. I think a lot of people use them and study cow vocalizations in behavioral studies. But we wanted to develop something that's not stationary and that's not manual recording, and put these out on individual cows that are out moving in a pasture. Now, cattle vocalizations, what do they mean essentially? Yeah, cows produce different types of vocalizations. There is a low frequency nasal call in lower stress situations or in close contact. And then there's those orally produced high frequency calls and used in longer distance communication and more higher arousal situations. There's also a mixed call, which is kind of a combination of the two. And recent research has been looking into using vocalizations to understand or assess a cow's affective state, and some really interesting work, especially around calving and the cow-calf relationship in terms of vocalization. So in a sense, I love these quotes, vocalization could be regarded as a narration of an animal's internal emotional state. And this is a useful commentary on their welfare. But the struggle is then understanding what it is that they're saying. So that was the aim for this. But of course, you do have to walk before you run. So the aim of this current pilot study was to use collar attached sensors on cows to collect a repertoire of vocalizations and then develop models to identify individual cow vocalizations and the types of vocalizations, and then use this in an outdoor pastoral farm setting, with the eventual aim, if we're able to do this, to then use it to assess affective state or emotional state in dairy cows and answer that question that I always get asked, is there a happy moo? So for this study, we used the Olympus digital voice recorder, which is an off-the-shelf dictaphone, essentially. This was modified with extra battery capacity to be able to record for up to 5 days. We placed this into a specially made canvas pouch and attached that to a collar on the neck of a cow. We had 10 cows in our study. They were then managed as per normal farm practice in New Zealand, outdoors and strip grazing in a group. We then had technicians and myself go out onto the paddock and to observe their vocalizations in person. Now I have a bit of a video here. I hope it comes through for you guys, but this is what this looked like. In this case, we moved them into a smaller paddock to be able to keep eyes on them easier. It doesn't sound like the vocalization's coming through on my end.
No, we can't hear them. We can see them moving.
You can see they're vocalizing. I'll let you know. So yeah, it actually turned out to be quite a challenge to manually observe vocalizations in a paddock, even in a small environment. So we definitely think that a tool for doing this automatically is necessary. So in total, we collected or observed, I should say, 709 vocalizations from those 10 cows. And this ranged from 3 to 452 vocalizations per cow. So we definitely had some quieter girls and one particularly loud one. Paul, the techno whiz, I should say, he then went through and listened to all of them and labeled them as closed, mixed, and open, and it is quite obvious to tell the difference. I have it on the next slide, maybe we can hear it, hopefully. And he also listened in for 709 other background noises from the data set. So that's everything that's going on the farm environment: birds, weather, vehicles, people, the cow's normal behaviors, and other animals on the farm. He then augmented the data set by generating 25 additional signals per each one of those isolated vocalizations and background noises, by altering the pitch shift and time stretch, etc. So we ended up having a huge data set of 36,868 little vocalization or sound bites. So as I said, we had kind of 3 main tasks for this work. The first one was to classify a cow vocalization versus other background noises. The next task was to classify the vocalization type: closed, open, or mixed. And finally, to identify or classify the cow that vocalized. So this was done using machine learning and using a convoluted neural network classification model in terms of looking at the closed, open, and mixed, and identifying vocalization versus other. So I don't think it's probably going to come through, hopefully not, or maybe it will. No, maybe not. I don't really want to moo today. But the closed vocalization, hopefully you can see on the spectrograms on the bottom here, the difference between what a closed looks like versus open and mixed. So closed, there's quite a lot of power in the lower frequencies, and that's that noise. In the open vocalization type, it's a little bit higher, so a lot more power in those higher frequency ranges. And the example I have in this one is a cow that's kind of bellowing. So she's, I'm very bad at mooing. I shouldn't do it. but the mixed, hopefully you can see from the spectrogram there that it is a combination of that closed and open. The top images, the top graphs up here is what we used to distinguish when cows were vocalizing over top of each other. So in an outdoor pastoral environment, they're in a mob or in a herd, and you can't really tell them to take their turn and go one at a time. So we used a bidirectional sequence to sequence short-term memory network. The top graph there in blue is the raw signal. We then go through to identify individual vocalizations. And I should say also, I don't have any images on this slide, but what we did to identify the cow that vocalized is because we had different audio tracks of each cow, we would attribute the vocalization to the cow that had the loudest vocalization on their track. So to assess our models on how well they did, for that first task, I'm sorry, I'm having a mind blank on this.
That's okay, Laura, you've got 2 minutes.
But essentially, you assess a machine learning model by using the training data set to develop the model and a test data set to test how well it is performing without the labels on it. And then you compare the success of the test data with what we observed in real life. So in this case, in that first model where we're looking at cow versus other, our model was extremely accurate and could identify a cattle vocalization in 99.5% accuracy. In terms of the second one, the classification of vocalization type, we had an overall test accuracy of 85.2%, so a little bit lower. And when we look at this in terms of the different classes, we can see that the closed and the open, the models did pretty well at identifying each type, but it's the mixed vocalization type that it struggled with the most and what brought down the score. And as we saw in the previous slide, it's understandable, seeing as it is really a combination kind of the two. And finally, for the classification of the cow that vocalized, this was just with 8 of the cows. As I previously mentioned, there were some pretty quiet cows and not enough data to be included in the data set. Overall accuracy was about 80%, but this did vary by cow. So yeah, the loudest cow that we had the most vocalizations for, it was far more accurate than cows that it didn't have that much in the
Laura,
data set.
Could you finish very shortly?
So in conclusion, we believe these collar-attached acoustic sensors can be used to determine vocalizations or identify vocalizations from cows in pastoral grazing conditions on farm. And that there's definitely, it's definitely feasible to use this technology to look at vocalization traits and try to understand a little bit more information about the state or the effective state of the animal or of the cows in this condition. But of course, as with a lot of things, we need a larger data set with more cows. And just as a little bit of sneak peek, that is what we are trying to do. We have included these these acoustic sensors on some recent studies looking at the experience of cows experiencing hunger or being overfed. So I'm sad that the audio is not working, but the visual will definitely provide a difference. So we've got this group of cows and then this group over here, which I think you can notice that they are bellowing a lot more. So acoustically, it sounds quite different. But that's the type of thing that we would see to be able to pick up from these collar-attached sensors in the future.
Oh, gotcha. Thank you very much. That's excellent. Thank you very much. Now,
thank you. Thank you for listening, and thanks to all of the team who were involved in the project.
Anybody got any questions? While you're thinking about asking a question, we've had some polar bear humming earlier this morning, and I've had some mooing by presenters. Maybe we could have a special prize for the best animal impersonator of the week. Right, there are no online questions. Yes, sorry.
Lene Juhl Petersen, Aarhus University. I would just like to ask if you believe that it would be more difficult to differentiate between the sound from different cows if you are in an indoor environment, because I would assume that it would be more difficult because they're closer to each other. Could you think about that?
Yeah, definitely. Like in this study, we only had 10, and then there was definitely overlap with a lot of the vocalizations. So I think in a barn situation, that would be an issue. Certainly, yeah, the acoustics of the environment is going to be different to pick it out, and then the proximity of the animals as well. I think potentially in a barn situation, a single microphone or an array of microphones might be something that's possible, especially if they're not moving in and out too much. And then there is some work in identifying, or there's some previous research looking at the cows have different voices, I guess, as we can call it. I'm sure there's a more scientific word for that, but it is feasible to sort of incorporate voice recognition, shall we say, into identifying individual cows through computers in the future in that sort of sense.
Okay, is that okay? Great, thank you very much. Thank you very much again, Laura. So the next presentation is also online. Francesca, is Francesca here?
Hello, can you hear me?
Yes, very well. Can we put our presentation on the screen?
Yes. Okay, so I'm gonna share my screen. Right, can you all see my presentation?
Yeah, thanks.
So my name is Francesca, and in this presentation, I'm going to be talking about using precision technology to investigate personality and predictability of movement and space using farmed calves and their associations with production. This is part of my PhD, which is funded by the BBSRC, and my supervisors are Jasmeet Kaler and Jorge Vasquez de Estada from the University of Nottingham. So I'm going to begin by talking a bit about why we study individual variation, even though having seen some of the other talks, I'm probably preaching to the choir already, but I'm going to, I guess, introduce how we started getting into this field. And so to begin with, prey animals, such as cattle, tend to hide their signs of disease, which means that diseases are often spotted in a farm environment quite late when the disease is severe, which increases both the cost of treatment and mortality rates. And that's why more subtle changes in behavior that precede clinical signs have been started to have been looked into a bit more to detect disease or stress. However, if we use a sort of a more traditional type of thinking and we use group averages to detect disease through behavior, it can lead to a lot of mislabeling. This is just a theoretical example of a behavior that might drop as a result of a disease. And we could just set a threshold and say that an individual that is, whenever the behavior drops below a certain value, that individual is sick. However, if we look at the second example with lots of individual variation, we can see that some individuals that are naturally behaving consistently below average will be wrongly identified as ill, which is why individual variation needs to be considered. In addition, if individual differences are indeed present within a group, this can be used to inform farm management and lead to a more individualized approach for ultimately better health and welfare of the animals. So individual variation has different levels, and I'm going to explain some of the definitions that we are using in this study. So personality, sometimes called behavioral type, refers to consistent differences between individuals in their behavior. We then have plasticity, which are the individual changes that are in response to environmental changes. Predictability is the residual within individual variation that is left over after the first two have been accounted for. And finally, we have behavioral syndromes, which are correlations between independent behaviors for the same individual. These concepts are quite well established in humans and some wild animals, but not so much in farm animals. Even though you can have a look at this paper from one of my colleagues, another PhD student from our group, Charlie Carslake, who has been looking at these concepts with feeding behavior. Recent research on cattle has identified some personality constructs in calves, such as the fearfulness and sociability personality types, or an exploratory active personality linked with weight gain. However, these studies are all using standardized tests, which are great at detecting personality types per se, but perhaps are not as generalizable and not very applicable to day-to-day behavior in a farm environment, which is what we are interested in looking at. And finally, they are not yet accounting for predictability differences between individuals. So there's been lots of recent advances in precision livestock technology, as indicated by this session and the other sessions of this day. And it has become possible to use a variety of sensors to measure behavior. And this allows to collect data that has both long-term data and also has the granularity needed to measure variation between and within individuals. Movement and space use in particular have been used to measure personality and predictability in some wild and captive animals. And we have chosen to focus on these because they are already closely linked to the personality construct of activity and exploration. So the aims of our research are to, first of all, detect personality types and differences in predictability through measures of movement and space use. Then measure potential behavioral syndromes and correlations between personality and predictability. And finally, detect any correlations with production measures such as weight gain. For our methods, we relied on precision livestock technology by using location tags that collected the coordinates at 1 Hertz of 60 calves for 40 to 48 days. We used this data to quantify the following behaviors in 4-day observational time units. So we had distance traveled and time in the feeder area, which are quite self-explanatory. And then the following 3 behaviors are computed based on the utility distribution. So we have core area used, which is the size of the top 50% most used area. Then total area used, which is the size of the top 95% most used area on the utility distribution. And then site fidelity is the level of overlap of the utility distributions of the 4 days within that observational time unit. For our statistical analysis, we used some of the methods that have started to become a bit more popular within the behavioral ecology field for measuring individual variation. So we first fitted mixed effects linear models for each of the behavior, which allowed us to calculate the repeatability. Repeatability is defined as the proportion of the total variation that is due to the individual. We then fitted double hierarchical models, which allowed us to calculate the coefficient of variation in predictability, also called CVP. This is the group level measure of how much individuals vary between each other in how predictable they are. And finally, we put all of these behaviors combined into a multivariate double hierarchical model to measure any correlations between and within individuals for the different behaviors. So here are some of our key results. In this table, R stands for repeatability, which again is how much individuals vary between one another in their average behavior. And then CVP is the measure of how much individuals vary between one another within the group for their level of predictability. And I've added at the end the results for a meta-analysis, which is very comprehensive and found an overall repeatability of 0.37 for several behaviors and several taxa. So our very high repeatability values for, especially for core and total area used, are indicative of an exploratory personality trait, as some individuals are consistently using a much wider area than others. And the moderate repeatability values for total distance traveled indicates an active personality trait, with some individuals consistently walking more than others. And then we have a consistent variation in predictability indicated by the CVP values, which is a novel result in calves. We had some significant correlations between personality type and residual intra-individual variability. For core area used, we had a positive correlation, meaning that individuals that tended to use a larger core area were also more unpredictable in the size of the area they used. This to us indicates, again, an exploratory personality, as the calves that prefer to spend more time, that have a larger core area would also increase the size of this area even further when something unusual is happening that they want to explore. We also had a positive correlation with between personality and predictability of time in the feeder area, meaning that the calves that spend more time in this area were more unpredictable in the amount of time they spent there. And this to us again could indicate exploration, but also an opportunistic trait, as these calves that spent more time in the feeder area had a tendency to spend even more time or less time, depending on what was happening and some external circumstances. We found some correlations between different personality types, known as behavioral syndrome, which indicates the presence of an underlying trait that's perhaps driving all of the behaviors. In our case, we found that calves that walked longer distance also used a larger total area and spend more time in the feeder area. And this shows a link between the active, exploratory, and opportunistic traits. We also found a correlation between the residual intra-individual variation of total area used and of time spent in the feeder area. This is what we call predictability syndrome, which to our knowledge is the first time it's been found in farm animals and only the second time it's been found overall. And it indicates the importance of predictability as a trait of the individual in its own right. The results that I've described so far have all gone into a paper that's just recently been published in Royal Society Open Science, and here's a link if anybody's interested in reading a bit more detail into this. We then collected data for an additional 80 calves for who we also have measured weight, and we found a correlation between daily distance traveled and weight gain, meaning that calves that were more active also grow faster. This is in support of the pace of life syndrome hypothesis of an existing trade-off between a sort of high risk, high reward, or also called fast strategy, and a low risk or called slow strategy.
Francesca, you have 2 minutes.
Great. So in summary, we successfully quantified a movement and space use behavior in calves using precision livestock technology. We did this in their home pen and using what we believe to be the most robust, up-to-date methods. We found consistent between and within individual differences in several behaviors, and we found behavioral and predictability syndrome. And finally, we found correlations with growth rate for these personality types. So this has implications for farm animal management, as different personality and predictability of the individual might affect their requirements, for example, space allowance. We can imagine that more exploratory and unpredictable calves might also adapt better to changes in the pen or introduction of other individuals, and accounting for these differences would ultimately result in reducing stress. And finally, the knowledge about these individual differences can be used for disease detection through behavioral changes. For our next steps, we want to quantify stability and plasticity of personality and predictability over different contexts by changing perhaps housing or group composition, and also detect correlations with illness and find which behavioral changes are good indicators of disease. A big thank you to the Ruminant Population Health Group of the University of Nottingham, and in particular to some of my collaborators for the paper and for this presentation. Thank you all for listening.
Great, thank you very much. I remember a time when I'm old enough to remember a time when when we talked about personality in animals, people thought we were crazed. Yes, I'm sorry, I didn't do a question earlier. Yes, please.
Mike Piscata, University of Bern. Great talk. Could you say something a little bit about the home pen itself? How big was it? What was there? And would there be any value in weighting certain areas? So say the area around the feeder, the drinker, if that would provide an extra level of granularity that would allow you to differentiate between animals.
Yeah, so the pen is 10 meters by 6 meters. It's quite bare. It has bedding over most of it, and it has an automatic feeder, a water trough, and some concentrated food. We didn't weigh the areas, but that's definitely an option for something to look into a bit more in the future. What we did is we only looked at really the location of the feeder as it being the sort of a very high quality area. But yeah, that's definitely something we could look into. It would be easy to implement with our data because we have obviously the location. So yeah, definitely something for the future.
Okay. I have an online one, which I'm very excited about. So I'll try this one. This is from Sergey Alindikin. Have you considered health status, for example, lameness? This could be a cofactor for mobility or resource use patterns.
Yes, so they are quite young calves, so we assume that lameness would not start to come in yet. However, we do health score the calves twice a week. So we are mostly looking at respiratory disease because that's the most, diarrhea and respiratory disease are the most common in calves. So that's what we've been doing, and we have included that in the model to account for any health effects.
And could you make it very quick?
I was wondering if you compare the results that you found with the standard methodology to assess personality trait in calves, like, the classic standardized tests or any other factor like that.
Yeah, that's a very interesting question. We want to do that. We have not been able to yet, just because we've tried to keep our study as non-invasive as possible. However, that's definitely something I'm interested in, and doing the classic behavioral tests. We've tried doing the sort of novel object approach, human approach tests in the group pen, but it didn't really work. It really needs a sort of standardized isolation pen and a testing environment. So that's thank you for the question. That's something that I'm interested in looking at in the future. I'm only in my first year of PhD, so I hope I'll be able to tackle all these interesting questions in the future.
And good luck. Thank you.
Thank you.
Thank you. Lovely. Kentucky. Thank you.
Go here. And hi, everybody. My name is Megan Woodruff-Setzer. I'm a PhD student at the University of Kentucky. And today I'll be discussing with you personality traits and their associations with precision technology measures of feeding and activity behaviors with the home pen and dairy. Just as an outline of what I want to discuss with you today, I hope to walk you through 5 main questions. First, starting with why are we looking at the relationships between precision technology measures and personality traits? What we measured with our precision technology measures, how we measured personality traits in dairy calves, and the relationships between those 2 measures. And then from there, I hope to discuss briefly what the next steps are for research in this area. So to start with that first question, why are we researching precision technology relationships with personality traits? Well, it kind of goes back to a hole we noticed that there is no on-farm way to assess dairy calf personality. So it's not really available to producers like it might be in some of these other instances that you see as examples up on the screen. But one of those examples is the sheep isolation box test, which has been used for a couple decades down in Australia. And it places these sheep within a box and measures their movement within the box as a level of reactivity as to represent temperament in these sheep. And we thought that we may be able to create or redesign this test for use in dairy cows. We did indeed follow up on that, and we built our own prototype of an isolation box test out of some plywood and zip ties. And we measured the activity within that box for our calves. And we were able to show variation across our population and the reactivity to the box, which was one of those check marks for being able to call it a personality test. And then we also compared it to more traditional standardized personality tests, including a novel object test, a novel person test, and a startle test. And from this, we saw that it was negatively associated with activity expression from those traditional tests. But we didn't want that to be the end of the road or the only route to explore in terms of looking for an on-farm personality test. And that's really where precision technology comes in. We know in the dairy industry already that precision technology is on the rise in usage. We're seeing that this is coming in as farm sizes are increasing, and we're seeing an increased labor shortage or decreased labor availability. So the precision technology kind of comes in and allows farmers to keep up with the individual in this low labor, high cow situation. And we know that the technologies that already exist and are commercialized on dairy farms are able to give us measures on animals' physiology, their production, and behaviors. And since we already have these technologies on farm, and we're using them to inform our management decisions already, we're asking the question, what else can we get out of this information or data that's already available to us? So to answer your question of why we are researching precision technologies association with personality traits, is because we must first establish the relationship between the personality traits and the behaviors measured by precision technologies to see if the technologies available on farm would be a good system for maybe eventually measuring personality traits with those precision technologies. So thus the objective of this study was to determine the relationships between various measures of personality traits and activity and feeding behavior measured by precision technologies. So what do we measure with our precision technologies? Our first technology was an automatic milking system that within our group housing system. Cows were trained to approach the feeder, and when they went unassisted, it was considered they had learned how to use it. And we also had in this system a grain feeder that provided starter as evidence to our calves. You can see here in this red circle how the machine was able to track the individual behaviors, as each calf had a unique RFID ear tag that communicated with the black panel that made it kind of hard to see. So that little green button. From our automatic feeding system, we recorded 4 behaviors for the experimental period, which was to about 81 days of age, with 2 weeks post-wean. And from this, we have a total milk intake, total rewarded visits, meaning when they approached the feeder and were eligible for a meal, and then total unrewarded visits when they approached the feeder and they were ineligible for a meal. And additionally, we had the total starter intake. Which brings me to our next technology, which is the leg accelerometer. Here on the image, we had a couple on our calves, but for the case of this study and what I'm presenting you today, I'm focusing on the ICE robotics IQ that is on the calf back left right now. We also had 4 behaviors that were looked at with this technology as well, including total steps, an activity index, which was produced by an algorithm from the company itself, total line time, and line value. So now that we know what we measured with our precision technology, let's take a look at how we measured personality traits in our dairy cows. Well, we wanted to start back with our traditional assessments of personality traits. So we did the novel person, novel objects, and a startle test at 24 days of age, where in this case, the startle test was the opening of an umbrella when it was approached by the calf, or a 5-minute lapse without the calf. From this, we took video recordings of these personality tests and we summed those behaviors across those 3 tests. And we ran those different behavioral variables through a principal component analysis, or PCA as I refer to it. And that PCA is going to be able to output or combine those behavioral variables together to kind of give us indications of the underlying trait that may be responsible for the behavioral expression of multiple behaviors. And thus we had 3 factors from that we retained, which we interpreted as fearful, bold, and active. Our other personality assessment was to bring back our isolation box test, which you can see here. And what we did was to place the cows in the box for a 5-minute period, where there were 5 accelerometers attached to the box 5 locations. And so the activity or movement of the calf or reactivity to the box was recorded for the period that they were in it. From this, we summed across the observations of each axis as they were tri-axis accelerometers. And then we summed all 3 axes together, and then once again, all 5 accelerometers to produce a unique numeric value to represent the reactivity of the calves within the activation box. And thus, going back to introduction, a measure or interpretation of personality traits. So the next step was to look at the relationships between these personality traits and these precision technology behaviors that we measured. So we utilized regressions to be able to do this, where we compared our personality traits represented by our total movement index, fearful, bold, and active, with 2 classes of behaviors from our automatic feeder representing feeding behaviors and activity from our leg accelerometer. So what relationships did we find with those regressions? Start with our total movement index. We did find some associations with those precision technology measures. More specifically, we found a positive association between total movement index and total milk intake, meaning calves that were more reactive within the box and moved more were associated with overall greater milk intake than their less active calves. Additionally, we saw that calves with a higher TMI were associated with a higher number of lying bouts. So then we can move on to our factors from our more traditional personality tests. Our factor 1, which we labeled as fearful, was positively associated with total milk intake as well. It was positively associated with total steps in the home pen, and it was positively associated with the total activity index, which makes sense as the steps and total activity index are very much interrelated with each other. Moving on to the final 2 factors that I had in my study, factor 2 bold showed a positive association with total steps in the home pen, and factor 3 active actually had a negative association with total milk intake. So just to kind of branch out and look at some other studies, we just wanted to emphasize that we're not the only ones who have compared personality traits with some precision measures, whether it's been labeled that way or not. Mead et al. 2018 looked at a novel environment, human approach, and novel object test, also did a PCA and got some factors from that. And they found that calves that were more exploratory active were associated with an increased pre-step milk TMI, dry matter intake for the non-common people, an increased starter dry matter intake, and overall combined starter and milk dry matter intake. Additionally, they did another study, pretty similar, where they also did the pre-standardized traditional test, the novel environment, human approach, a novel object test, but they combined vitality scores from the first day of life with that to run into their PCA, and then compared it with the automatic calf feeder behaviors. And from that PCA, there's 5 factors, and from the 2 of those that were more related to personality traits, fearfulness had a negative association with drinking speed, and exploratory active had a positive association with the number of rewarded visits. So I know I threw a lot of that to you right then, but I just wanted to briefly emphasize what I'm trying to drive home, which is personality traits are related to precision measures of technologies that we already have on the farm. Now, in what way we may need to do establish some more research to have clear ideas of what these relationships are. As you know, we're looking at these behaviors that go into our PCAs for our interpretations. It's very explorative, and it might be different in her paper or my paper what behaviors we're labeling as certain traits. So it's important to explore this more to have a clear idea of how those precision technology behaviors are related to personality. So just kind of drive home or re-emphasize what I covered in this study. We did see that different measures of personality traits are associated with precision technology measures in dairy calves up to 2 weeks post-feed, where we had classes of personality traits associated with feeding behavior, specifically TMI, factor 1 fearful, and factor 3 being associated with milk intake, which is a very big deal in dairy calves. And then TMI, or total movement index, fearfulness, and bold were associated with activity measures within the home. I'd like to go next into the field of research, looking at if we're able to go back to that original point and maybe do a little bit like what Francesca did and use these precision measures to define the personality and maybe forego the traditional, maybe more time-consuming personality test. Additionally, I'm very interested to see if we can look at how personality relates to deviations in behavior around stressful times for these calves. So maybe how they cope with weaning or dehorning in that early kind of vulnerable period. So with that, I'd like to thank you all. Any questions?
Thank you very much. Thank you very much, Megan. Right. Has anybody got a question? Yes. In the middle. With the blue shirt.
Real talk. Ben Look from the University of Bristol. So I got a bit surprised first that we describe fearfulness and boldness usually with the same dimension, meaning that calves that are fearful are also not bold. But you have two different dimensions, and that the two of them, fearfulness and boldness, are related positively to distance goals. So can you just explain it?
Yeah, so we definitely had an interesting PCA outcome that I don't think a lot of people had, as we had kind of on my fearfulness factor, like latency being positively associated, at times been attentive, very positively associated. Meaning cows are taking long to approach novelty, and they're like more hesitant and watching it more closely. Where the boldness had like a very low loading of latency for a different latency, and they spent a lot of time touching the person or object. So it didn't feel right to. I mean, they were loading separately, so there was something different going on there. And you have to remember that, I'm interpreting these labels the best I can with how the behaviors load on the PCA. So it does kind of put a limit on maybe the agreement we may see with other tests, but there were also slightly different tests than like the novel environments wasn't in there as many tests other ones have a novel environment. I do have a novel environment test on these calves, and I hope to do another PCA with more well-rounded test inclusion and see if that persists of the loading on separate factors.
Okay. Great, Margaret, and then we'll get there.
Yeah, Margit Bak Jensen from Aarhus. Hi, I'm Ragnar. I have a question of cause and effect. Because you find a relation between fear and intake in using these automatic feeders? So might that be? Might that be because animals that have less success in learning to use these feeders also become more fearful or more pessimistic or whatever?
That is a good question. I did include learning ability in my models when running my regressions, and they weren't included or significant in any of them. I do not remember off the top of my head if I eliminated that in this specific regression or not, unfortunately. But I do think that from anecdotal experience, that some calves maybe like to go to the nipple to like cope or for comfort if they're maybe more stressed. That maybe that has to do with it. But that is an anecdotal theory that maybe I think we work into it.
Yes, great. Sorry. The gentleman in the end of the row in the middle.
Hi, Erlang from Germany. Maybe I missed an aspect, but I would like to ask, did you do the personality tests repeatedly? And if yes, at what time interval?
All four personality tests, so the novel object, person, and startle test, as well as the isolation box test at one time when they were 24 days of age. And I was basing that on literature that showed it was consistent from pre to post meeting. So I made the assumption based on literature that it would be consistent.
Okay. Thank you very much. Megan, thank you very much. Great, that's lovely, lovely.
Hi, my name is Teresa Johansson. I am a research assistant at the Swedish University of Agricultural Sciences. And today I will be presenting a new approach suggesting that dairy heifers do not show uh, a stable circadian rhythm upon entry to the milking herd. So just for some background, on several dairy farms, cows are often introduced to the milking herd shortly after calving for the first time. This can both be a disruption to the herd, as it can disrupt the social hierarchy, and also stressful for the individual who is going into the milking herd. And so on the individual level, she needs to build social relationships, find her place in the hierarchy. She must learn the routine of the milking herd, whether that is parlor milking or automatic milking system. And she is also typically in a new environment, as she's typically not housed in the milking barn prior to her first calving. So this can have potential impacts on the cow health, production, and welfare. Some studies have looked into how these introductions can impact different individuals, but they've typically been on a research farm with smaller groups. So we wanted to see how this translated into a commercial setting using sensor data. So our aim then was to use sensor data to determine if heifers' behaviors become more stable within the 45 days after introduction to the milking herd. So to do so, we used 2 farms that have this cow view system already installed, which is a GIA technology, one located in Sweden and one located in the Netherlands. And we chose 15 individuals from either farm and collected their individual data. And in Sweden, this was during 2019 with a break during the summer months due to the animals being on pasture, and in the Netherlands during 2020. And so the data collection started on the first full day in the milking herd, and this was typically 1 to 2 days after the calving. And then we followed this individual for the 45 days. And so this is what the cow view tag looks like. It is placed on a collar on the top of the neck of the cow, and these tags then collect individual positioning data with a 1-second fixed rate through anchors that are placed throughout the barn and a triangulation system. So the 2 farms, you can see the floor plan here. And so the farm A, the animals that we collected data from were housed on the right side of this red line, as this is where the high yielding and the newly calved cows were housed. And there were roughly 100 individuals in this group. And this farm had parlor milking system. And farm B, you can see on the right side, and this farm had the milking herd altogether with about 200 individuals. And this one had robot milking. And so the positioning data, when it is collected, is then categorized as cubicle, which in these figures is labeled as the beds, the feeding area, or in the alley. And for the alley positioning data, it can be differentiated between walking and standing. However, for this study, we chose to combine the 2. So here is an overview of how the data look like for farm A. This is the figure for farm A, and each individual then is the horizontal black line. And you can see the day the data collection began and when it ended. And then there were some days that had missing data due to a system crash. And so these days that had more than 8 hours of missing data were removed. And the blue lines indicate the total number of cows introduced on a given day. As these were both performed on commercial herds, the cows are moving into the milking herd continuously. And so we wanted to see if this had an additional effect on the individuals moving into the milking herd. And the dashed lines are claw trimmings, as we thought maybe the behaviors would also be a bit different the days following the claw trimmings. And so these are these dashed lines. And the blue lines are the longest ones are 3 individuals, and then progressively as they get smaller, it's 2, 1, and then 0 cows being introduced that day. And then here's an overview also of the data for farm B. Here we don't have any dashed lines for the claw trimmings, as these are done continuously by the farmer every week. And so to start, we wanted to look at an overview of the time budgets for all 15 individuals on each herd. And so we split these 45 days of data into 5-day means for the time in the cubicle, the alley, and in the feeding area. And so for the Swedish farm, we saw that days 1 through 5, the cubicle and alley time are pretty similar. They're almost the same. However, numerically, we saw that there was quite a difference then on days 6 through 10. The cubicle occupancy increased while the alley time decreased, which suggests that perhaps in days 1 through 5, the individuals were quite restless, wandering around the barn looking for a cubicle and their place in the hierarchy. We also noted a bit of a numerical change here during days 21 through 25, with a decrease in the cubicle time and increase in the alley time again. And we thought that this could perhaps be due to the timing of the first ovulation for these cows. On farm B, these patterns weren't as similar. They already have quite an increased cubicle time on day 1 through 5 already, but we did note that there was a slight increase again, day 6 to 10, and again, a bit of a decrease in the alley time. And then we were hoping to see maybe an effect of heat again. However, we just saw a bit of a decrease in the cubicle occupancy. However, not really a difference in the time spent in the alley. We, of course, were very interested in seeing how this introduction to the milking herd actually affects each individual rather than the herd average. So then we looked into the individual cubicle occupancy. And so the left graphs here for individual 1 and 11 are the time spent in the cubicle, or the proportion of the day spent in the cubicle. And then we plotted the residual variance and the slope of this to see how this behavior was varying from day to day as time went on. And we just looked at this for the first 20 days. So some individuals fell into the category of having a positive sloping residual variance, with the cubicle occupancy varying more and more as time went on. And so we chose to define these as becoming less stable over time. And there were about 4 cows total, with 2 on farm A and 2 on farm B. And others fell into the category of having a negative sloping residual variance, and we then defined them as having a more stable cubicle occupancy as the time went on. And there were 5 of these cows on farm A and only 2 on farm B. And the rest of the individuals fell into the category of not having a significant residual variance at all. So we could not necessarily define them as becoming more or less stable. And there were 8 of these on farm A and 11 on farm B. And I chose to present 2 examples here of how they can look quite different, even if they are categorized in the same way. Individual 2 has a proportion of the day spent in the cubicle ranging from as low as almost 20% up to 60%, which in hours can be about 5 to 14 or so hours, while individual 6 remains between 40 and 50% of the day spent in the cubicle during these first 20 days. So they still look quite different. And we were also interested in seeing that the milking herd a bit easier and a bit smoother. So thank you so much for your attention.
Thank you very much, Teresa. Or maybe it makes it worse because they know what's happening. They know what's coming. Yes, the lady at the back.
Hi, Jacinta with Wageningen University. Thanks for a very interesting presentation. I was wondering, you look at whether there is a difference in the diurnal patterns. Are you also going to look at what these actually look like? So when are the cows performing certain behaviors?
We have not looked into this, but we definitely could. There are daily timestamps as well of the positioning data, so we could see when exactly they are performing each behavior. Yeah, that would be interesting.
Is that okay? Anybody else? Yes. In blue.
Thank you, Teresa. Beautiful talk. Ben Nicol from University of Bristol. I just wondered if from your data, lots of individual variation, I think is very cool. And do you think that in the sample source you have, there are some cows that were more vulnerable to the transition period? And what pattern would you expect to be associated with a harder time to integrate within the herd? Would it be that animals that are stable over time or decreasing or increasing their?
If there are risk factors to having a more varied type of-
Yeah, that was poor integration in the herd.
Not that we know of. We didn't necessarily look at the health records or anything, if there could be an effect of something that makes them more or less stable when they get introduced. I think that would be something to look further into, is if there are other differences between these that are very varied versus the ones that aren't, and kind of figure out why that is. And then perhaps it's something to breed on, or if we want them to be more stable in their time ranges.
Right. Oh, okay, very, very quick.
Thank you. Akagok, Wageningen University. You say they're in the cubicle, but are we sure if they're standing or lying there?
We are not. That is a drawback of this system, is it doesn't differentiate between lying or standing behavior. We're actually going to go to the barn next week and do live observations to see if we can see how much they are lying versus standing in the cubicle.
Great. Thank you very much once again to me. So finally, we're going to hear from the Netherlands. Okay.
Hi, everyone. As said, my name is Akagok, and I'm a researcher at the Adaptation Physiology Group in Wageningen University. My talk has nothing to do with the Olympics or with swimming, but it has to do with synchrony. So I thought it's a striking image to immediately show you what I mean. Yeah. So synchrony is performing the same behavior at the same time. And there may be several reasons why animals are doing this. It could be social facilitation or a little mimicry, where animals are motivated to do what other animals are doing. On the other hand, it may also be that there are concurrent responses due to other factors. So in humans, rush hour is not because we all like to be on the highway together, but we all want to be at work at the same time. And in the same way, cows may go to the feed bank because it's fresh feed delivery. Cows are said to have a strong drive to perform the same behavior as others. So you can see the calf in the bottom is already looking what the others are doing. And as a result, there is a hypothesis that a high degree of synchrony within a herd may indicate positive welfare, especially for the subordinate animals. Because if everyone can do what he or she wants to do at the same time, this would then lead to synchrony. However, there's a limited knowledge of synchrony in cows. There are only a few studies that use scan sampling, and we don't really know much about the level and the consistency of synchrony, whether it differs between days, within farms, between farms. Well, there's increasing use of sensors, especially on intensive dairy farms. And though these sensors don't measure behaviors that we would like to know, at least they measure lying and standing accurately. So we know that on commercial farms, they use these sensors for estrus detection, and we may use them for lying or standing synchrony. So we could use that for continuous monitoring. So that was my aim, to explore synchronous lying behavior in dairy cows on different commercial herds, and to focus especially on the level of synchrony. So should we expect 100% of the cows to lie at the same time, or are these proportions lower in practice? We were also interested in knowing when this behavior occurs, because this is said to differ between systems, and how long this behavior occurs within a day. So to study this, I used the data of 8 commercial dairy farms The majority of these cows, so not all of them, had an accelerometer, and this now down to about 44 to 186 functioning sensors on these different farms. All the farms had Holstein Friesian cows that they either milked with a robot on 2 farms, or with twice daily milking on 5 farms, or 3 times daily milking on 1 farm. And grazing was performed on 6 farms in summer, or what I refer to as summer, May till September, for 5 to 8 hours per day between morning and afternoon milking. Lying space per cow didn't vary much, but usually it was about 1 cubicle per cow, with 1 farm having only 0.9 cubicle per cow available. The data that I had came from the ISAE robotic sensors, where I had the lying time per individual cow per 15-minute block for a whole year, calendar year 2019. So essentially, I had 96 values per cow per day for the minutes that the cow had been lying. These I process. First, I remove the duplicates, because when you get them from the system, it's a bit messy. I remove incomplete days, and I remove days with more than 23 hours of lying or standing, assuming that these were on the shelf instead of on the cow. Then I averaged all the cows to 1 herd pattern for every calendar day for each farm. So here you see an example. On the horizontal axis, you see the time within the day. And on the y-axis, you see the percentage of the lying time, which I assumed was the percentage of cows that was lying. So in this case, you see that the cows are lying from midnight. About 60% of the cows is lying. First morning milking, you see all the cows get up. Afterwards, they lie down again. They're up for a second milking. Afterwards, you see a short dip that's related to feeding. And then what? So how does this relate to synchrony? We could say that if 60% of the cows is lying, we would quantify this as a synchrony lying. So if we would do that, this would translate in about 9.5 hours of synchrony for this day. We could also consider that this is a too low proportion. So we could say, well, let's put it at 70%. And that would result in only 3 hours of synchronous lying time, only occurring in early morning between midnight and 4 a.m. So for today, I've used thresholds of 60% and 70%, the ones I just showed, to determine synchrony per 15-minute block. And then I computed the daily synchronous lying time for every herd by multiplying these by 15 minutes. Then I looked at the effect of farm and of season, where summer was access to pasture on some and winter was indoor for all cows, and an interaction between the two. And I've looked at the correlation with daily lying time of the herd to see if there's additional value to this indicator. So first, what is the proportion of cows spent together that is lying? So I looked across all these calendar days what the highest proportion was within the day of cows that were lying. And this ranged between 50 and 100%, indicating that, well, at some point during the day, at least half of the cows is lying, but it's not so often that all cows lie down together. And the mean and median were 78%, meaning that you would expect at some point of the day to have 78% of the cows lying down. Well, with my threshold of 60 and 70%, that means that already you have many days that there's a 0 because synchronous lying time will not occur. So it's good to keep that in mind, especially that this gets worse for the 70%. So when does this synchronous lying then occur? On the horizontal axis, you see again the time of the day. On the y-axis, you see the proportion of days that have synchronous lying occurring at that time point. And I did this for both thresholds. So for example, at 4 a.m., you can see that in 60% of the calendar days, the threshold of 60% of cows lying down was reached. And the threshold of 70% was only reached in about 30% of the days. Lying was most common at night, so from midnight to about 4 or 5 a.m., with a small peak around the day, and hardly ever between 4 and 8 p.m., then increasing again in the night. And we see the similar pattern for the 60 and 70% threshold, suggesting that even though they measure different values, they might measure the same thing. And then I was wondering, is this 50 or 60% of the cows of the days being synchronous lying? Does it mean that it differs between farms, or is it very variable? So I studied this for individual farms. So here you see essentially the same graph, but now all these lines represent different farms. And you can see that the brown line, farm H, at 4 a.m. in the morning, 100% of the days has synchrony in lying. whereas the orange and yellow line, farms B and D, we say no synchrony at all. And this is for winter. In summer, we see the same farm pattern occurring, but we see a big difference during the day. And this is all farmed with pasture access. So we see that in these farms, when the cows are in pasture, synchronous lying occurs in about half of the days. So we see there's variation between farms and also due to season. So how long do these cows then lie in synchrony? And I show these results only for 60% threshold, where in summer we find that there's about 6 hours of synchrony on each farm, ranging between 2.7 hours in farm C and 7.9 hours in farm H. In winter, this is a bit lower, 5.5 hours per day, where it ranges from 1.6 hours again on farm C and 9.1 hours again on farm H. We then look at the different systems. Farm A and B apply the milking robot, and we don't directly see a visible effect of strategy that these farms are different from the others. If we look at grazing on the other hand, and we've seen that already, we see a visible effect of season, where not so much synchrony is increased in summer, but synchrony is lower in winter for some farms, especially B, C, and D. Last, I looked at the correlations between lying time and synchronous lying. So on the horizontal axis, you see lying time varying between 9 and 14 hours per day, and synchronous lying fluctuating from 0 to 15 hours per day. And these all had moderate to high correlations. And you might expect this, because if more cows are lying for longer, it's more likely that they do this in synchrony. At the same time, however, you see that with a lying time of 11 hours, synchronous lying time fluctuates from 0 to 10 hours per day. So there's a huge difference there in variation that is not captured in this average lying time. So I think it has other information to provide. So to go back to what I've shown, I think we shouldn't expect full synchrony in dairy herds, because we've seen that the highest proportion of cows lying during the day is about 78%. Synchronous lying time occurred mostly during the night and on pasture, which is what we expected and what farmers expected as well. And it highly depends on the threshold that you use. And the higher you go with the threshold, the less sensitive it becomes, because the more zeros you'll get. However, if we go down with this threshold, is it still a valid measure of synchrony? So that will be something to discuss. As an indicator for positive welfare, at least it's easy to compute. So I'd say it's feasible, although not all cows have a sensor. And the farm values appear stable. So the variation within farms is smaller than between farms. So this seems to be promising, that it could be a reliable indicator. I didn't do any validation, but based on these results, at least we see that there's no clear impact of robot milking, which was expected in the beginning. So that's a good sign. And that there's variation between farms that may be attributed to something of the welfare measures. In winter, we saw less synchrony in some of the grazing farms. We discussed this with the farmers to see, well, what do you think there could be a reason for this? And we were talking about disturbances. Maybe these farmers leave more lights on or are closer to roads or highways, or there might be more competition that cows will go feed at night. We also discussed stall comfort. So farmers acknowledge that even if you have one place per cow, cow may not like to lie down in every place. And two examples of this are alternate occupancy, where cows don't like to lie down in between two other cows, and perching, where cows don't perceive the quality of the stall as good enough. So maybe instead of the cubicles per cow, we could use the cows themselves to see if they perceive these areas for lying as actual areas for lying. So with that, I'd like to end my talk with the take-home message that synchronous lying time can be evaluated easily using sensor data, but its validity as a positive welfare indicator requires further research. And if you want to know more about that, please come to talk to me during lunch. And for now, I'd be happy to take any questions.
Thank you very much. Mark.
Mark Rutter, Harper Adams University. I should mention my university. I didn't mention it earlier. Very nice talk. I wonder if they sort of force synchrony in the winter. Different farms have different lighting schedules. You mentioned lighting. Some farms will have it on a timer. Some farmers will come and switch the light off at random times. I just wonder, because what you're picking up is really nice diurnal variation. So have you explored the lighting conditions, and might that explain the issue?
I haven't explored them directly, linked them to the data, but the farmers were there in the meeting that I presented it, and they didn't come up with, oh, this is my farm and I recognize this. So in that sense, no, there's not a direct link. And I think most farmers at least will switch off the lights in most parts of the barn at night.
Limited.
João Costa from the University of Kentucky. I was wondering if you look at the association between synchronicity and some of the patterns of line, like line bout number per day, line bout length, things like that, that we already have some association with stall comfort and some other methods.
Thank you for your question. I've only looked at relations with line time, as I showed, but not yet with line bouts or line bout length. No, but that would be interesting to do, to shed some more light. I think the main thing that we thought that farmers didn't like only 50% of their cows to lie down at night. But then this doesn't give any handhold where to start. So it's good to explore more of the behavior.
Thank you, Lena.
Lena Lid from Swedish University of Agricultural Sciences. Very interesting. I was wondering if these cows had one eating place per cow, because maybe this could be the reason why they're not synchronous. They have to go and eat
Yeah, I still have to look into this, but it's not a relation as clear as what we see in the synchrony. But I am planning to dive further into this.
I was thinking if they have like two cows per eating place or 3 cows per eating place could have an effect.
Yeah, no, and it's never as bad as that on the commercial farms that we have. So we have worse conditions with the roughage intake control bins. So it will never get as bad as that. So I think it won't fully explain the situation, but there might be a link there that is worth exploring. Yeah, thank you.
Thank you very much. Thank you very much once again. So now we have poster time. Could those who are presenting their posters come to the front so they can queue up so we can do this efficiently as we can? And could you bund them up? The final poster will be an online presentation poster, but otherwise everybody's here. Right. So ready? Go, Jennifer.
Okay, so hi, I'm Jenny Weller, and I'm a researcher at AFBI, which stands for the Agri-Food and Biosciences Institute. And we're a research farm based in Northern Ireland, and we're really fortunate in that we have our own infrared thermography system that's been installed in our cows' dairy unit. The system was designed to alert farmers to the potential cases of mastitis based on udder temperature. However, we wanted to know if we could use the system to detect other welfare issues that can be characterized by changes in body temperature. We've actually found some really cool stuff. We've been using it to detect changes in eye temperature in response to a presumably stressful event. So if you would like to hear a little bit more about that, come and find my poster or me. We're the poster number 50 in the first poster room next to the really cool poster about socialization in rabbits. So don't get too distracted by that. But
thank you very much. Right, sorry. Yashim here? No? Right, can we go to the next one? As far as I understand, the only online one is the last one. So no, sorry.
Marcia Andrews, University of Minnesota, presenting this on behalf of my grad student Rial, who actually graduated last month and got a job at the University of Minnesota teaching animal behavior and welfare this week. So she couldn't be here. So this is an exploratory study she did with 25 farms. Where we looked at behavior collected from automatic milk feeders, feeding behaviors, and how they were associated with various management practices. And those on the bottom here, the light intensity at the feeder, the amount of milk fed at the peak on the different farms, the bedding depth, and the group size, percent fat in the milk, and weaning age of the calves were associated with various behaviors. Come to poster 52 to learn more about it. Thank you.
Thank you very much. Now, Cecily, great.
So my name is Cecilia. I'm from Aarhus University, Denmark, and my poster is about validation of scan sampling and sampling techniques of pigs during transport. And really what I want to show is this video. This is, to my knowledge, the first time we have video from inside the vehicles of these pigs in this age. And it was quite a challenge because the deck height is 60 centimeters. The pigs are around 40 centimeters. And we have around 27 pigs in here. That was difficult, but we managed. So if you want to know how we did it, come talk to me.
Blimey, thank you very much.
Hi, everyone. I'm Emmeline Sudman. I'm from Iowa State University in the US, and I also did some scan sampling validation from my master's project where we were looking at nutritional enrichment in the nursery. And we looked at, comparing continuous into validation for feeder use and enrichment use in this environment. And if you're interested in learning about our enrichment projects or about our scan sampling validation, come see me at poster 54.
Thank you.
In humans, we can distinguish between early birds and late owls. So what part of the day are we active? But did you ever consider if it would be the same for pigs? So, and are they consistent in that? Because if we know that, we can also easier recognize if they deviate from their own behavior. So we use electronic sow feeders to explore this. And what is interesting is that those sow feeders are already often used. They're very robust, but they're usually used for management purposes and not for welfare, for example. So there's a lot to explore. So if you're interested, my name is Iris Bouwmans. I'm from Wageningen University, and you can find me at poster 55. Thank you.
Thank you, Iris.
Hello, I'm Frank Tuitens from Belgium, presenting poster number 56, and that is introducing you to a new project, in the European project. It's a Horizon Europe project that we call WISH, and it stands for Animal Welfare Indicators at the Slaughterhouse. So what the overall aim is to monitor and improve animal welfare as cost effectively as possible by monitoring animal-based indicators at the slaughterhouse using automated sensor technologies. We focus on broiler chickens and fattening pigs. And so I don't know why this poster is in the session of PLF or CATSOL. But if you're interested, also if you're interested in being involved, we're still looking at broiler welfare experts, fattening pig experts to join our expert panel. And there's also various positions available for PhDs who want to be involved in this project. Thank you very much.
Great, thank you very much. As an English person, actually, cattle can mean all kinds of livestock, including, I think, historically, including wives. Right, sorry.
Hello, I'm Bianca from the Federal University of Santa Catarina in Brazil. And during my master's, I investigated public opinion about farming crates and some currently available alternatives. And after doing this research, I got curious if we as animal welfare scientists have been addressing the public concerns in our empirical studies with animals. So we did a systematic review to investigate that and also identify how animal welfare has been assessing these systems. And we found many interesting results, and I'm not going to give any spoilers, but one of them is that all the variables we identified in the selected literature can be fitted in these categories listed in the slide. As you can see, no study investigated affective states, which has been pointed by the public as an important concern, and as we have heard in many talks during the conference, is an important aspect of animal welfare. So please come find me at poster 57 if you want to hear more about it.
Thank you very much. And I would like to thank you all for coming to this session. I think it was totally interesting, and thank you for your contributions and questions, and thank you very much to the presenters too. Thank you very much. Lunch.
Hello, my name is Lydia Nobe. I am presenting the poster 58. To date, there's no standardized protocol to assess co-welfare at pasture.
I apologize.
Oh.
There's a final poster that's online. Is it coming?
Okay. Do you hear me? Hello?
Oh, was it there and did it go?
Do you hear me?
Yes.
Okay, I started, but I will do it again.
Sorry. Yes, please do. Sorry, it's my fault.
It's okay. Don't worry. Okay. So hello, my name is Lydia Nobe. I am presenting the poster 58. So today there's no standardized protocol to assess co-welfare of pasture, and validation of welfare measures is really crucial to build an operational protocol. So the objective of this study was to investigate reliability and repeatability of 6 potential behavioral measures to assess grazing cows' welfare. So to do it, photos and videos were observed twice by 5 observers to assess inter and intra-observer reliability. And also the measures were carried out on 48 grazing cows, 2 days apart and during 7 visits to assess repeatability at short term and also over the grazing season. So if you want to see the result, you can come to see the poster 58. Thank you for your attention. Thank you.
Thank you, and sorry for interrupting you. Right. Thank you to all the presenters. Thank you to the audience. Thank you for your questions very much. Have a good lunch.
Što me tera da se vraćam od cite koga beram, tuka si. Ti si to i toliko dobro, jasno shvaćam, porušiš se ko ljuboven cilj. Moj te soništa, tvoji Ti si to što oči budeš plamen i ovako praviš ovaj grad. Ti si to što so nežno stopiš kamen, po tebe dušo čustvujem glad. Seke naprava da te začuva. Ova srce najdalek, je te ljubav eden vek. Sekoj den, sekoj čas, da te gledam, da te milujem.